You know, when we think about crypto mining, we've kind of been trained to believe one simple truth. Bigger is better. More hardware, more power, more wins. But what if that's not the whole story anymore? Today, we're going to dig into a really fundamental shift that's rewriting the entire rulebook. For the longest time, the answer to that has been a pretty resounding yes. It was a simple equation. More power equals more hashes, which equals more rewards. But what if the game is evolving? What if it's shifting from a simple test of brawn to a complex test of brains? All right, so here's our game plan. We're going to start with the classic mining game, just to set the stage. Then we'll dive into this idea of BYOS, or bring your own solver. From there, we'll see how it completely flips the script on core ideas like difficulty, effort, and yeah, even luck. And finally, we'll look at what this all means for the new algorithmic arms race in crypto. Okay, first things first. To really get why this new rule is such a game changer, we have to have a solid handle on the old game. For years, classic proof of work has been all about one simple, powerful idea. Think of it like this. Classic proof of work, that's a 100-meter dash. Everybody lines up, they're all running the exact same race, and the person with the most raw explosive power wins. Simple. But this new model, qPoW with BYOS, it's more like a decathlon. Miners show up with their own unique strategies, their own custom-built algorithms, or solvers. And all of a sudden, it's not just about who's fastest. It's about who's smartest, who has the best strategy, the most elegant design. So let's see how this one change just ripples through the entire system. And we'll start with the first big concept that gets totally turned on its head: network difficulty. So in the world most of us know, like with Bitcoin, difficulty is pretty straightforward. It's like a global thermostat. When it goes up, it gets harder for everyone, no exceptions. It's a blunt instrument that treats every single miner exactly the same. But here is where everything changes. In a BYOS system, this quote just says it all. Difficulty no longer punishes all miners equally. It stops being this universal punishment and becomes something way more sophisticated. It becomes a filter, one that rewards the clever and weeds out the inefficient. What you get is this incredible, real-time Darwinian evolution for code. As the network difficulty cranks up, the weak solvers, the ones that are poorly designed, they can't hang. They get filtered out. But the really elegant, efficient solvers, they thrive. They sail right through and start grabbing a bigger and bigger slice of the pie. The network itself is naturally selecting for the fittest algorithms. So if difficulty is now this dynamic, selective force, that obviously begs the question, what happens to effort? This is another one of those terms that miners live and die by, and under BYOS, its meaning gets a whole lot more interesting. In the old days, effort was simple. It was a measure of literal sweat and electricity. Did you have to grind away longer than the statistics said you should to find a block? If you did, your effort was high. It was a direct reflection of pure computational work. Well, you can pretty much toss that definition in the bin now. Since every miner is running a different custom solver, you can't compare work done apples to apples anymore. So instead, effort becomes a statistical measure. It's about how your specific solver performed relative to its own unique probability of success. It's a measure of performance, not just brute force. So how on earth does the network figure this out for everyone? Well, the process is pretty elegant. A miner submits their performance data, the network looks at the timing of their solutions, and then it compares that against the statistical expectation for that particular solver. This lets the network assign a normalized effort score, which basically levels the playing field. And the result is pretty cool. A super optimized solver could consistently show low effort, proving its superiority, even if its raw hash rate is identical to a competitor's.
Okay, this next one, this might just be the most mind-bending shift of them all. We have this deep-seated idea that mining luck is pure random chance, but in a BYOS world, that's just not true anymore.
Traditionally, yep, luck in mining is just like a lottery. Every single hash you compute is a brand new ticket. Each ticket has the exact same microscopic chance of winning as everybody else's. It's pure, beautiful, unadulterated randomness. And here's the kicker. Luck is no longer just a single variable. It's a formula. It's this incredible hybrid of three different things: the actual quality of your solver, the randomness or stochasticity that's built into your solver's method, plus that little bit of pure universal randomness that was always there. This explains a phenomenon that would otherwise seem completely impossible. If you see a miner who seems to be consistently lucky, they're just finding blocks way more often than their hash rate suggests they should, it's not magic. It's engineering. They have literally built a better solver that reduces variance and can aim more effectively. They're not just buying more lottery tickets, they are fundamentally buying smarter ones. So what happens when you completely redefine difficulty, effort, and luck all at the same time? Well, you change the entire endgame. The competition is no longer about who can build the biggest, loudest engine. This table just lays it all out so clearly. Look at the shift down the line. Difficulty goes from treating everyone the same to favoring solvers that scale well. Effort goes from being about raw work to being a statistical measure of quality. Luck transforms from pure chance into a function of design. The big takeaway is obvious. The advantage isn't just raw hardware speed anymore. It's hardware plus solver intelligence. So here's the bottom line. The Bring Your Own Solver model fundamentally transforms crypto mining from a brute force competition into an algorithmic arms race. The new battlefield isn't just about silicon anymore. It's about numerical methods, intense optimization, and absolutely brilliant code.
And that leaves us with a really fascinating question to think about. In this new world where the smartest piece of code can actually outperform raw power, who really has the advantage? Is it still the person with the biggest wallet who can afford the most hardware? Or is it the clever developer who can design the most intelligent algorithm? The roles have changed. And believe me, the race is on.